Hello students, continuing with the previous lecture, we were discussing about assembly language program. So, I told you that assembly language program is written in the form of mnemonics. Now, when a program is written in a language other than machine language, a computer cannot understand it. Consequently, a program written in other languages has to be translated in machine language before it is executed. The translation is done with the help of a software. A program which translates an assembly language program into a machine language program is called an assembler. So, in an ordinary kit, assembler is not available. The programmer first of all writes program in assembly language and then fills up the machine code corresponding to each mnemonic. Again, I am repeating what happens. The programmer first of all writes the program in assembly language and then fills up the machine code corresponding to each mnemonic. This is called hand assembly. The codes are written in hexadecimal system. So all the codes are written in the hexadecimal system. Rather than using the binary system, we are converting the mnemonics in the hexadecimal system to minimize the error. And the hexadecimal codes are fed to the microcomputer using keyboards. In microprocessor kits, there is an arrangement for converting hexadecimal codes into binary codes. The program for addition of two numbers in assembly language with hexadecimal codes is shown in this slide. So this is the assembly language program and this is the conversion of each mnemonic of the assembly language program in the machine codes using hexadecimal system. So the programmer writes a program in mnemonics, that is assembly language, with comments as it is easier to understand and faster to write. Then he fills up the machine codes which are to be fed to the microcomputer. So here till this slide only I have discussed about the programming of, that is introduction part of programming of microprocessors. Now in the next slide, as I have already told you about what is instruction, as I have told you what is program and what is instruction. So now I'm going to introduce you to the terms opcode and operand, which you might have come across while going through the microprocessor lab experiments. So what is opcode and what is operand? The instruction of a microprocessor consists of two parts: opcode, that is operation code, and operand. So the first part, that is opcode, specifies the task to be performed by the computer, and the second part, that is operand, tells about the data that is to be operated on. So for example, here I have shown an example MOVAB. So here MOV tells you, or the MOV tells the microprocessor to move the content from register B to register A. So MOV tells about copying the content from register B to register A. And what are the, so here the opcode is MOV and the operands are A and B. That is the contents of register A or the content of register B, which is going to get copied from one location and get pasted in the other location. So whenever I'm saying this operand can be an 8-bit or 16-bit data. This operand can be a 8-bit or 16-bit address, can be internal registers or a register or memory location. Like in this instruction here, operand is the internal registers. So whenever I'm saying operand is a register, it is understood that the data is actually the content of the register. Whenever I'm saying that operand is the memory location, so it means the data is the content of the memory location. Operand is the content of the memory location. Whenever I'm saying that operand is a 8-bit or 16-bit address, it means it is the content of that address. So what is operand? Operand is the data on which the operation is going to get performed. And what is opcode? Opcode tells the microprocessor about the operation. What type of operation need to be performed? So here, like I have shown, the instruction MOV A, B 78. So this is an assembly language. This is a program, this is an instruction written in the assembly language. As I've told you, any program which is written in the form of mnemonics is your assembly language program. So this is an instruction of assembly language where MOV is the mnemonic, AB are the operands, that is the content of register A and B are the operands. And what is the opcode? The opcode is the 78. So opcode for every instruction, like you might have, when you were going through the microprocessor lab experiments, you might have come across the opcode term, and you might have seen that for every instruction there is a specific opcode. So for every instruction there is a opcode, and whenever we are going to enter that instruction in the microprocessor, we write the opcode and the operands. Like for this instruction MOV AB, we will just write the opcode 78. And the microprocessor, after decoding this 78, after this 78 is in the hexadecimal format. 78 is written in the form of hexadecimal. So after converting 78 into binary form, the microprocessor, after decoding that binary format of 78, the microprocessor will get to know that it has to move the content of register B to the register A. So here I have shown for 8085 microprocessor list of instructions. These are the assembly language instructions and their specific opcodes that Dilip sir also might have shown you in his group, that shared every opcode of every instruction for the 8085 microprocessor. So as you can see, for every instruction there is a opcode. So this opcode tells the microprocessor about the task to be performed. And what are the operands? The operands are this part. Other than mnemonics of the instruction, they are the operands. So I am ending this lecture here. We'll continue with the classification of instruction of 8085 microprocessor in the next lecture.